Hello, everyone, and a very warm welcome to this webinar where we will be talking about the CoRal project, a new Danish speech dataset developed by a bunch of people, where we have two guests today, Danish Sottrup Nielsen and Martin Carsten Nielsen, who will be presenting some of their work with us today. My name is Jeppe Lindegaard. I am the event and project manager here at Danish Sound Cluster. And for those of you who don't know us, we are a non-profit member organization who facilitates the sharing of knowledge and research and experience. And yes, today, like I said, we will be talking about the CoRal project, which is a project by Alvenir, Corti, Alexander Institute, Agency for Digital Government, and University of Copenhagen. As you may have noticed, Lars Målø from Corti was going to join us today, but he had to fly to Atlanta for a very urgent matter. So unfortunately, he won't be with us today. So we'll probably cut the webinar a bit short, but we'll have, like I said, Danish Sottrup Nielsen from Alexandra Institute, who will start off, and then Martin Carsten Nielsen will follow. He is the co-founder at Alvenir. And I will just stop sharing my screen here. To start things off here, I'd just like to hear you guys a bit about the collaboration you've been doing. So Dan, could you tell us what is Martin's best skill in your collaboration?
Best skill. So I think it's probably like, it's always difficult to pinpoint like one precise thing, but I think it's some mix of kind of his optimism and like a team player aspect, like always willing to like work towards a common goal, and there's usually never any like obstacles or arguments along the way. It's like, yes, we're in this together, and we will strive towards this goal together, which is quite nice, like high morale kind of thing.
Cool. So Martin, I'd like to ask you the same. What's Dan's best skill?
Thank you, Dan. By the way, this isn't scripted, guys, so that's very nice of you to say, Dan. Did actually not expect it to go that way. No, I've thought now I had more time to think about it, obviously, but I would say that Dan is thorough, like thoroughly thorough, and to an extent that I've never had the experience of before. So if there is a bug somewhere on line 2849 of whatever little repo that you're spending a billion years looking after, Dan will find it and he will fix it. And basically that's what makes things tech when you come around, especially if you, in Dan's own words, work with like an optimist like me, then every now and again there will be a bunch of things just going around and somebody needs to kind of do the nitty gritty as well, right? And Dan is really good at picking that up.
Right. So what is that attention to detail? What does that mean for the collaboration?
Well, it means that you can trust the results, right? It means that whatever we put out, and I think that's true for everybody involved, also with Lars and Anna Søgaard from Deco and so forth, that we're very much like, I can take the role that Dan is pointing to here, like of just being the team player, because I know that there will always be somebody making sure that everything that we put out there is up to par. So coming from the outside, you might look in and say we spend a lot of time making sure that things are exactly right, and we do. But it's also because we're trying to do something that is unprecedented, right? We're making a publicly funded project to put out very sensitive data in a way that hasn't been done before. And we're also trying to kind of set the scene for both the modeling, but also like the learning, the data collection, and we just need to make sure that the foundation for that is right. So I think like the attention to detail that is actually being shined by everybody on the team is just incredible in doing that.
All right. Thank you very much, Martin. Now enough patting on each other's back here, I think. For those of you who just joined us, we're talking about the CoRal project developed by Alvenir, Corti, Alexandra Institute, Agency for Digital Government, and University of Copenhagen. And today we have Dan Schottold Nielsen from Alexandra Institute and Martin Carsten Nielsen joining us from Alvenir. And unfortunately, Lars Molo had to cancel because of an urgent matter. So now we'll just jump straight in. And Dan, will you take the floor, please?
Yep. Great. Let's see. Cool. So yes, so this is the exact same slide as Jeppe just had. So this is I'm going to do two things. So firstly, I would like to give, like you could say, a bird's eye view of the project, just so everyone is aware. Firstly, what is it? Like, what are we aiming to do? How are we aiming to do it? So kind of very, you could say, again, bird's eye, theoretical kind of what's the plan? And afterwards, I'll go into what has actually happened so far and what kind of experiences and learnings that we got on the way. Cool. So CoRal is one of these very typical fancy abbreviations within machine learning. So this stands for, well, Danish, even though Danish doesn't appear in the abbreviation, conversational and read aloud or read aloud speech dataset. So the key here is, of course, that it's speech dataset. It also will include models, but kind of the core part of the project is development of the dataset. And I just want to delve into, so we have two different kinds of speech in this dataset. We have the read aloud, where a person is literally reading out some text on a screen. So that's one type of data. The other type of data is conversational, where we have people talking to each other. So it will be more spontaneous. It will be perhaps more modeled, more broken up compared to kind of the more clean read aloud text. So we will include both. Okay. So Jeppe gave like a brief intro. This is just like a one slide, just so you have an idea of who I am. So as Jeppe mentioned, my name's Dan. I'm a senior AI specialist at the Alexandra Institute. I've got a PhD in mathematics, postdoc in machine learning, and have been working with NLP since 2019, around when Transformers was kind of brand new / up and coming. And I've been working in that, like both in governmental institutes, startups, and now this kind of pseudo university industry company, which Alexandra is. Okay. So the goal, so this is kind of the bird's eye view aspect that I mentioned. So the goal of the project is, or the vision, if you will, is to build this Danish speech datasets, which should hopefully elevate Danish speech technology. And because this dataset will be freely available to everyone, this should help with both new products and existing companies, but also help create new companies and jobs and so on in this sector in general. Okay, so you might ask, like, why a Danish dataset? Like, why is it exactly that we need this project? So firstly, so I'm just gonna like summarize the points here. You will get all the slides, so you don't have to worry about like taking screenshots or whatever, noting these things down. The short story is that speech technology is a growing field, has been growing quite a lot in recent years, but as with many things in machine learning, especially within like this language sector, like text and speech, the main focus has been on English. So Danish, because we are a small, low resource language, we kind of have to take it upon ourselves usually to make sure that we follow the trend, that we are able to use all the new technologies and tools that are available out there. Yes. So the aim of this project, very briefly, you could say, is to build a Danish dataset. Again, will be open source. This dataset will be a mix of the read aloud text that I mentioned previously, as well as the conversational speech. So it will be mostly read aloud, so roughly 2/3 read aloud. And the main reason for that is that all the conversational speech has to be transcribed. Like someone has to literally listen to the conversations and read down exactly what was being said. That's very resource intensive. Where read aloud text, you of course have the transcription already because that's what they read aloud. So this is a compromise between we want as much conversational speech as possible because that's the more natural sounding audio, but we also would like as much volume. So this is a compromise being between the two. Okay, so the project itself is running over 3 years roughly, and it started this summer. So this data set will be produced in 4 different iterations. So we see the kind of iteration loop here. So where we, in each iteration, each of which will be roughly 6, 7, 8 months, we will go through a recruitment stage. So here recruitment basically just means we need speakers because that's what the data set is about. So these speakers needs to come from a very diverse mix of the population, because one of the aspects or one of the priorities of this project is to minimize bias in these speech models. So we focus a lot on having a broad representation of both gender and age and dialects, as well as accents when speaking Danish. So we want to encompass all of those variations of Danish. So it's a very ambitious goal, but that's the goal of the project. So first stage is recruitment, then we do the actual recording, then we validate the recordings, like make sure that they are actually saying what they're supposed to. In case of read aloud speech, for instance, that they are reading, like actually reading the text that they were supposed to. Then the text is, or the speech is annotated, the conversational bit. So annotation here just means transcription, like write down what they're saying. Then we release the resulting data set. And then model development begins on that data set. So now we have a full iteration of data. So each iteration will be roughly 250 to 300 hours of speech. So based on that and existing speech data sets already available, we build models, figure out like what are these models good at and what are these models bad at. And then we make sure if they, for instance, are after the first iteration, if they're really bad at a specific dialect, then we know, oh, we need to recruit more people with that dialect for the second iteration. So this is the kind of 4-stage active learning setup, if you will, where we go through this loop 4 times, and hopefully, given that we attempt to minimize the bias in each iteration, that the resulting data set will have a very broad representation, enabling us to train models that have as little bias as possible. Okay, so that's the bird's eye view. So in terms of our method, so I mentioned that we need to get all the dialects of Denmark, like we need to, or of Danish rather. So these are all the regional areas that each have their own dialectal variations of the language that we speak. There are quite a lot of dialects in Denmark. Even though it's not a huge country, we still have 32 very distinct dialects in the country. So what we did to start with was analyze all the different unique features of each dialect. Like some of those are overlapping. Like it could be that 3 different dialects, they each have the same kind of dialectal variation compared to the rest. This means that we can, like a result of this analysis is that we don't need all 32 dialects in the data set necessarily. What we need is we need all the dialectal variations. And to get those, the results of this analysis showed that we could get by with 12 dialects in total. So what you see here on the map is all the dialects that are number 1. Those are all necessary because those are kind of some of the most unique dialects in the Danish language. When it comes to the following numbers, then we have choices because those are quite similar. So for instance, so we need all of the 1s. When it comes to the 2s, we see that there are some 2s in the northern bit of Jutland and in the southern bit of Jutland. So those have a lot of dialectal features in common. So to be able to get a complete picture, we need either people from the northwestern bit of Jutland or southern bit of Jutland. That would, in both cases, capture those dialectal variations. Of course, not like proper Sønderjysk, which is at the very bottom of Jutland, because we all know that that's a special dialect that is quite distinct. And we also see that that has the number 1, that we need that dialect. We can't just substitute it for something else. So anyway, that's the description of this map. So that was the first analysis that led us to figuring out where we need to go in the country to get voices, so to speak. So what do we actually do? So I mentioned that we have read aloud text and conversational text. So what they're doing in the read aloud section is that they will read aloud random sentences from Wikipedia. It's not completely random. We have done like quite a lot of hefty filtering to make sure that what they're reading is actually Danish. What they're reading is kind of, it's actually a sentence, like rather than just reading out formulas, for instance, or reading out a bunch of tables and so on, but they need to be sentences that occur naturally, so to speak. Wikipedia was chosen because it has to be, we want to release this data set, so the text needs to be in public domain. Wikipedia is kind of a good choice of that, or natural choice for public domain text. So what we do is that we make these people read aloud some text, and they will read aloud, or they will read 20 minutes aloud from these sentences from Wikipedia without any noise, just like vanilla, nothing. Then we will induce noise, not in the audio itself, but in the headphones of the people. So in their headphones, they will listen to traffic noises while they are reading out these text bits. And the reason for that is that we have different intonation when we are surrounded by noise. So it's not about the noise itself, it's about us raising our voice in a different kind of way. And we want the models to be able to support those kind of variations as well, of course. So one without noise, 20 minutes with traffic noise, and 20 minutes with, you could say, people noise, where there are people talking in the background and so on. So that's the read aloud. For the conversation, they match up in pairs, and then they have 20 minutes of free conversation, so to speak, like where they are just talking about whatever, as long as they're not talking about personal identifiable information, crucially. So they're not allowed to like talk about themselves, their names, or where they live and so on, because again, this will be a publicly available data set. So we want to kind of protect the identity of all the speakers, of course. So that's free conversation. Then they will have 20 minutes of prompted conversation where we have some cards that prompt them to do certain things. That could be like directing a person on a map, for instance, that you have to turn left there and then turn right at the next intersection, or whatnot, like various different prompts. And here we will also have this noise aspect. Okay. So as a compensation, the people will receive a 200 kroner gift card. So that turns out I will get back to that. Just keep in mind that they are compensated, but some of them were surprised at this fact even, but let's get back to that. So some learnings. So this was like both a bird's eye view and now also kind of the practical setup of how we did things. So what did we or have we learned so far? So we've been doing this for a bit less than half a year now-ish, 4 or 5 months, and we are nearing the end of the first iteration. So we have kind of quite a lot of experience already in terms of how to conduct these kind of large-scale data collection. Cool. So firstly, who signs up? So we were quite surprised at the kind of the very or a heavily dominated demographic, which are resourceful women above 60 years old. There are, like, turns out there are a lot of those, and they are very willing to help out to, like, in kind of, you could say, cultural projects like this, where they have to donate their voice to kind of the greater good. So they are very, you could say, conscious of the societal impact and so on. They're very, helpful. They want to help. And a lot of them, as I mentioned, were very surprised to hear even that there was a compensation. Like, they just wanted to help. They didn't want the gift card or anything. Several of them, even dozens of them, traveled for more than 5 hours just to record kind of their input to the data set because they just cared. So that was a big surprise to us as well. Another surprise, so I mentioned that there was an overweight of this demographic, but of course, it's not solely this demographic. There was kind of a wide variety of different both ages and genders and so on, but this was like the dominated or the dominant demographic. Some of these women, they also kind of dragged their husbands along. And their husbands, some of them participated, but surprisingly, a large number of the husbands, they did not want to participate or to help, not help, but they didn't want to donate their voice, and instead waited in the lobby until their partner was done and then kind of got on with their day. So that was an interesting finding as well. When it comes to why they do this, so a lot of them are very interested in languages in general. So that was like a general phenomenon. They think that it's important to have their unique dialect documented in a database like this. And several of them have also used like voice assistants. This could be Siri on an iPhone, or some have Alexa and so on. And they noticed that these typically mispronounced Danish words and generally do not understand what they intend to say. So they would like that to become better as well. They are typically worried about their voices being heavily commercialized, like where a typical thing was that they would rather not end up hearing themselves on a bus, like announcing the stations, for instance. So we made sure that in the kind of contract that we sign with them, to explain exactly what this data set is used for, so that they are informed, so that they know exactly what they are donating their voice to. It's quite a hefty task to explain kind of speech technology, complicated data sets, storage, GDPR, all these things to a lot of like kind of the broader public. So that has been a challenge as well to like attempt to formulate that in a concise manner, which is easy to understand as well. So we're not just like throwing a bunch of jargon at them. So that has been a learning experience as well. The last one here is that we were quite surprised. We were fully expecting more than half of the people who signed up would not show up. Like that was what we expected, because it tends to be this way, especially when there's no consequence for them not showing up. But we were surprised that more than, I think it was 80 or 90% of them who signed up actually like showed up and came and donated. So that was a positive surprise. So generally low dropout rate. And as I mentioned, that there were quite a few of them who didn't expect to be compensated either. Of course they did, but cool. So the current status here at the end of the project. So we had our first warm-up at ITU on April 27th. So that was like to test the recording setup and to fix bugs in the software and so on to make sure that that was working. We had a second warm-up at the Copenhagen Main Library at the end of May, where we had quite a lot of people, and that was like a stress test as well of the setup to see how that worked. And then the official kickoff was at June 19th at Aalborg Main Library, where the Minister of Digitization and Equality, who recently left but now has come back as Minister of Digitization and Equality, also participated. So that was very, very nice. Current status in terms of amount of data, we have more than 200 hours of recorded speech. So we are roughly on schedule. So I mentioned it was around 250 to 300 hours per iteration. So we expect this first iteration to be done in January at some point, which means the data will be hopefully released around there, as well as models. Conversational part is currently being transcribed. Of course, that's quite a big task, but we are hopeful and optimistic that that will be done in January. So the targets reached. So we've got 65% women so far, which is great. That we have like a very large representation of both women and men. And we have reached, for this iteration, we've reached the target in the capital region, as well as Middle and Northern Jutland. So I mentioned that we had this essentially like a big spreadsheet of like all the dialects that we need. So we have already achieved everything we need in the capital region, Middle, Northern Jutland. So we're focusing on the rest of the areas here in December and January. And I mentioned that one of the big demographics represented among the speakers were people in their 50s and above. And we have reached like more than here 150% of the target. So that's like we've got more than we need of that demographic. So we're focusing on the other demographics as well in the upcoming months and for the future iterations as well. So yeah, so that's what I had. So that's the current status of the CoRal project when it comes to data collection. So I'll stop sharing here. Jeppe, you are muted.
I am muted indeed. Yes, thank you very much. Thank you very much for your presentation here, Dan. Now I feel like asking you. You mentioned a few things surprised you in the process. Are there any things that did not surprise you?
I guess tons, probably, because there's so many things that could go wrong. And surprisingly, I suppose one thing which did not surprise us.
It's okay. You can get a second to think about it while I ask a different question.
I guess one thing that didn't surprise us is that we expected there to be more than enough willing speakers for the data set. And that ended up being the case. And that was primarily because prior to the official start of the project, we had arranged a deal with all the libraries, or most of the libraries in the country, which we were so happy about, that they were willing to supply us with like office rooms or rooms at the libraries, and they were willing to like create announcements as well to get all the people local in that region and municipality to come join. So that was a lot of very positive feedback. So we expected there to be quite a lot of people, and thankfully that was correct. Otherwise, that would have been tough. But yeah.
All right, cool. I've got a few other questions, but I might just save them for later after Martin has done his presentation, because I think some of the questions, Martin, you might want to chime in on as well. So yeah, thank you very much, Dan, and I would like to leave the floor to you, Martin. And like I wrote in the chat, when Martin has finished his presentation and we've done a quick Q&A, we'll finish up with a panel discussion, and maybe talk a bit about the perspective of this speech data set, what it will change for us and different sectors in the future. So now, Martin, I'll leave the word with you, and yeah, take it away.
Wonderful, thank you, Jeppe. So I don't have an introduction slide with me on it, so I'll just follow Dan's excellent lead and just tell you two things about me. My name is Martin, as you've probably gathered from now. I have a background from DTU as a mathematical engineer, and then I was a research assistant there for a while until we founded Alvenir. Alvenir space is open source speech recognition, and today we do a lot of different things, but the basis of it is that we work with speech technologies. So when we were being set up for this, Jeppe gave me the super easy task of trying to demystify machine learning. And I thought good and hard about how I would do that. And then I agreed with myself to not bring a bunch of formulas for once and try to do it from a more philosophical perspective. And now we've been in nitty-gritty with the data. Let's see if I can actually get this to move. So I want to kind of bring you back a little bit to the bird's eye perspective and just start out with a little bit of motivation for why we're doing all of these things, and also because I think that relates very nicely as to why should we even model these things. So the overarching question here is it even important for machines to be able to formulate and comprehend speech? And for us to be able to answer that, I decided I would look into what a general person does over his or her lifetime. So assuming we sleep about 1/3 of our lives, it takes a couple of years to learn to actually communicate, then we're awake for about 52 years of our lives. And we spend roughly 42 of those years communicating in some shape or form. And now if you granulate that even further, then we end up spending about 12 years of our time speaking and about 19 years listening. And then the remainder of our time is spent reading and writing. So that means that about 75% of the time that we are awake, we are actually engaged in vocal communication. And from that number, I kind of gathered that it wasn't too far-fetched to conclude that speech as a modality is quite important for humans. And therefore, it also stands to reason that we'd want to be able to communicate with new forms of intelligence that not necessarily human, but artificial intelligence is what we're talking about here, through this medium, which is speech. Obviously, that then begs the question, what is speech? This concept that we have decided is something, right? And then you can get a bunch of different answers. So I went on the internet and I asked ChatGPT, as any sane person would do. And ChatGPT says that speech refers to the expression of thoughts, feelings, ideas, or information through the use of spoken language. So it's something about formulating ideas and then kind of expressing that. So if you go to the big brother Wikipedia, you get something slightly more technical. It says that speech is human vocal communication using language. And then it specifies that each language uses phonetic combinations of vowels and consonant sounds that form the sound of its words. So we get a little more physical here. It's something about making actual sounds, and then back to kind of the ChatGPT interpretation of using those sounds to then portray meaning. And then if you go super nitty gritty and ask an archive of medical doctors, then you get that speech is the bodily interference with the egressive airstreams from the respiratory system to generate noises of different sorts on the one end, and the eardrum responds to the different frequencies of those noises on the other end. Um, and I think together these three probably kind of answers the question, what is speech? So to kind of try and give you an idea of this, I've made an example to make it a little more visual. So essentially, when we talk and communicate, what happens on the one side is that we formulate speech. That's a process that happens in the brain. Once we have done that, or actually while we are doing it, we then communicate with our body, and there is this bodily function that we got off the internet to vocalize these ideas. And when we do that, we create acoustic waves. And these waves are essentially vibrations in the air that are then transported, or in this sense, to a microphone that is then transported to you guys. And then your eardrums or your ears receive those vibrations, and that gives you a perception of this sound that was made in this acoustic wave. And then that is processed and transported to your brain, where speech comprehension happens. And the purpose of this demonstration is essentially to say that this phenomenon that we call speech can actually be broken down into a lot of different small compartments or small subparts and subtasks that needs to be accomplished in order to make an accurate model of what speech is. And essentially that means that we have a speech production side and we have a speech recognition side. And with CoRal, we are addressing both. But today we're primarily focusing on the speech recognition part of things. So then now we know what it is that we're trying to model. That's like a fundamental question for starting to doing modeling. And then the good question, of course, is how do we go about actually making that happen? And one answer to that is statistical modeling, which is this family of models that uses data and statistics to try and derive information or try and model something in the world. In our case, these particular scenarios or sub-processes that I just explained. In statistical speech recognition, there are essentially two major paradigms for doing this. There's what I will refer to as the classical paradigm, which very much seeks to break down each of these processes into its own problem, and then try and model that particular problem. So that could be for the interpretation of sounds, that could be using Gaussian mixture models to make a model of all of the phonemes in a particular language, and then using that information that you now gather, so that goes from audio into a classification task, and then you could take that output and then you could try and infer how likely are transitions between phonemes. You could use hidden Markov models for that to then actually create a automatic speech recognition system. So then you essentially granulate the entire problem of speech and then model each part or compartment separately, and then you combine them in some elegant way to get a system that actually understands and recognizes speech and emulates that human process. The other way, which has gotten way more traction because it's a billion times easier, and it's also what we're doing in CoRal, is the deep learning paradigm. So the major issue with deep learning paradigms as compared to traditional things is that they usually require more data. On the bright side, it's also easier for us, which is what we're doing with CoRal, to get data in the right format for them, and we can usually accept more noise. But what the deep learning paradigm does, as opposed to the more classical aspect, is that it seeks to essentially learn a single function or approximate a single function of this entire space. So I would say, Martin, you understand speech. You have this capability of doing speech recognition. I want to try and emulate that. And I believe that I can learn the patterns that you are using through data. And then what it really matters is how can I then identify the right data points to learn that and learn those patterns. And then there are some things that can be done in terms of architecture, which is often what is referred to when we talk about different deep learning models. But essentially, you can do it in a bunch of different ways, and we've been able to do it for a long time. And it's more the details of how good things are that changes in that space. Which brings me to probably the most important part of how do we actually go about making this happen, because both of these approaches, so we accept, and to this day we don't have a better way of doing it than statistical modeling. So if we accept we need to have statistical modeling to do speech recognition, then we also need text pairs or training pairs of sound, audio, and text in some shape or form. For classical modeling, you would need annotations on a phonetic level to know what phonemes were at what exact time to be able to make that model. In the deep learning paradigm, we do what we do with CoRal, and we say we need to know what was being said in this particular audio stump. But common for the two is that you need to know what was being said at one time, and then that gives you enough information to be able to actually model this phenomenon that we call speech. So that does sound fairly simple, right? And then that begs the question that you're all asking is what's the caveat? And the good news is, to some extent, there isn't actually one. Automatic speech recognition as like a modeling problem is largely solved, and that comes back to this point that I had before, that we can actually model things in a billion different ways, and they're actually surprisingly good. That means that we can achieve human level performance in many settings, for instance, with Zoom calls or phone calls, or especially with when we talk to Alexa and whatnot. There's a lot of scenarios where we can actually build super cool new products that positively impact our lives using this quote unquote new technology, because we've had it for a long time at this point, but it's only been really good for a couple of years, and that's why we're kind of beginning to see it. So these are all matters of fact, and they're great, and they work given enough diverse training data, which is the point that Dan has also been making. So obviously that means like, okay, it works the majority of the time, and there's a secret to that, and there's also luckily a secret sauce to fixing it, at least we believe so, is that even though these systems are great and they work a lot better now than they have for a long time, they do struggle in a couple of scenarios. So one of the things they collectively struggle with is recognizing given names that hasn't been part of the training data. So that could be exemplified by if Dan and I were to create a new startup, and we sit down in a basement and we consider what are we going to name this particular product, and then we come up with something new. It could be Gemini if you were Google, for instance. That has most likely not been set in the data that the models have been trained on, and therefore the chance of actually retrieving that information is close to zero. It can happen, and there's some modeling things that might make it work in some cases, but in a lot of cases, new given names are pronounced in a different way from how they're spelled. So that's one particular area where these systems usually struggle. Then, at least from a CoRal perspective, something that is much more important is the pronunciation of specific words. So that could be, for instance, if you have very heavily accented speech, people with speech impairment or impediments and whatnot. So basically anything that interfere with this bodily process of manipulating the airstream to create the voices that we can then comprehend. And there's a lot of things that can interfere with that. And if the data set that you use to train these models are not diverse enough, haven't seen that, then there is very, very little chance that they will be able to generalize to that particular problem. And therefore, the chances of them actually recognizing properly somebody from South and Jutland is close to zero. And then there's a different thing, which is when the language kind of evolves over time. And it does. So if you were to listen to somebody speaking like early radio recordings from the early 50s or 40s or something like that, it's entirely different from what we would speak today, how we would speak today. Some of the words, so it's kind of a mixture of the two others, but language evolves over time. We get new words. My younger cousin speaks in a way that I don't understand. And that will evolve over time, right? So that's something that systems can struggle with as well. So in essence, ASR systems are super great. They do a lot of fantastic things. but they do struggle when the training data that are used to train them has too little variations to actually account for the world that we want them to operate in. And from like a CoRal perspective, that sadly covers a lot of Denmark, because there's a lot of people in Denmark that do have a couple of these, especially the pronunciation thing, because Danish as a language encapsulates so much variation, which is not present in the data that we have access to. So essentially what we've been given with CoRal is a chance to curate that data, so that we can make some really, really great models for that particular problem. And that's essentially what we're doing. So that's all I had on the modeling side. I hope you didn't miss the equations too much. I'm more than happy to catch up on that if somebody needs it.
All right, Martin, thank you very much for your presentation. That was very thorough and very interesting. I just have a quick thought here. Like you said, the language will kind of evolve. It has evolved and it will still evolve. So once you kind of finish with this, which you may never will, how much maintenance will this need to have going forward?
Yeah, so it obviously depends on which part of the problem and how language evolves, right? So one of the issues is words, and arguably updates the data set over time will make a lot of sense. Probably also with accented speech and so forth, it's hard to put an exact number to how much maintenance it will require. It will probably need to be updated, at least in some sense. Now I'm just swinging out words, right? But let's say every 25, 50 years is probably a good idea, at least. Something in that scale, if new words are being introduced, but I don't think that's not really the case for CoRal. Like CoRal is doing what CoRal does really great, and is going to be doing really great, is encapsulate the demographics of Denmark. So essentially, if we expect Southern Jutlandish to change significantly at what point, then we might need to go in and do something about that particular part of the data set, and then a part of the data will, given some amount of time, probably be more historically accurate than it will be future accurate. But we'll kind of be able to monitor that over time. And one of the things that's like our ambitions with open sourcing everything here, both the data and the process and the learnings, is also that hopefully that will be something that we as a society can kind of grasp and do that maintenance over time, because that's true for most data, but just having it, I think, is incredibly important.
All right, thank you very much. I have a question here from Lars in the audience. He's asking, are you working with speech synthesis of dialects as well?
So I guess I can grab that. So in the CoRal project, we are also there is a speech synthesis component. Like it doesn't take up as much, you could say, budget/time compared to the speech recognition aspect, but it is there. However, in the speech synthesis aspect, we do not focus on specific dialects or anything of the sort. So in that case, it will be, you could say, typically the standard city Danish, if you will, in like Aarhus, Copenhagen kind of thing, typically. So what we're planning on currently is to have 2 speakers. So these will be professional speakers, not volunteers, as distinct from the rest of the data set. This will be a separate speech synthesis data set of 24 hours of each speaker. So this will be a man and a woman. And this will also be open source, like both the data set, and we will also build speech synthesis models based on these. But again, they will not have any of the, you could say, more unique dialectal variations of Danish. There will be more of the, you could say, the news anchor variant, if you will, like a more, like, you could say, official speech or voice/dialect.
All right, thank you very much. And Lars, if you have a follow-up question, you're very welcome to ask that. I can even open your mic if you want to elaborate a bit. But I would like actually, Martin, just turn back to you a bit here because I was thinking, do you think training models with language is more difficult than training models with other data?
No, that's the short answer. I don't. I mean, I've been in this time. I've also been working. I think audio is as difficult. I mean, I think it's the same thing as with any kind of domain expertise, right? You need to understand the domain and you need to understand what we're modeling. But in a lot of sense, I think language has because it's kind of I like to look at it as kind of an encoding task, right? Like we, as I said, we formulate thoughts and then we can communicate that in some sense. And that's kind of us trying to encode whatever is happening in our brain. So it's very close to that. And that means that there's a lot of error modes that will be there. But like modeling it per se is actually quite well understood, right? We understand the physical aspects of language. We understand even how we produce it. Or some people are able to accurately generate a synthesis sound based on EEG images and so forth, right? So it's like the physical aspect of it is super well defined, and that makes it easier for us because that puts constraints on the modeling part of it. And there's some technical aspects to it. I think for not a couple of, like a decade ago, maybe it seemed very difficult because you had very limited capable models for it, right? So like during the first AI winter, where deep neural network was kind of put in the freezer for a while, it seemed hard to do these things because we didn't have these very, very largely parameterized models that we do today. But that's not like the modeling part of it. That was just because we didn't have hardware and model capabilities to do it at the time. But like doing a good speech recognition model is essentially the same as doing a good image recognition model.
Okay, thank you. So since we have the English has been here for a while, um, is there any big differences now that it's Danish? Is it Danish a harder? Is it a more complex language? Is it, or how do you see it differ from English?
I think we can both answer a little bit on this Dan, but I'll be happy to give in my first thoughts on it. I mean, this is a question that I've been asked a lot, and I've pondered it a lot. And for a long time, my answer was yes, in some sense, because there are some intricacies of Danish that might be difficult to model. I think what makes Danish harder in some sense is that Danish, at least if it's like the applicable practical Danish, is what I pointed out in the presentation as well, is that actually governs a lot of different, not just dialects, but actually small languages. Like there are specific Bornholmske words and there are specific Sønderjyske words. And kind of encapsulating that in a meaningful way requires a lot of attention, right? But I think like the biggest issue with modeling Danish as compared to English at the moment is just simply the lack of available data. And then there's a lot of regulation that makes it slightly more difficult to do things. Yeah, that's my take anyway. I don't know if I hope you agree somewhat then.
Yeah, I think I do. Like, I agree that of course there are notable differences between English and Danish, but I think from the point of view of modeling it in a deep learning kind of way, using that approach, there is not really any big difference per se between the languages. Like we use almost the same alphabet, so the alphabet is roughly the same size. This would be different if you were working in, say, I don't know, Cantonese or something, where suddenly you have thousands of letters, then you would have other challenges. But in that sense, we are very alike to English in the sense of the morphology of the language. Of course, we have different types of sounds and so on, but the models are capable, you could say, of picking up the various variations of sounds. Of course, that means that we can't just like take, you could say, an English speech model and just merge it into Danish. Like it would have to be a Danish model that have heard a lot of Danish, which we thankfully have available. But in terms of modeling the language, I don't see a big difference between English and Danish. Like German would be the same. Any Scandi in almost any European language would be the same. Like Latin alphabet-based things, even like Greek would probably be the same. where I think like they have a different alphabet, but because the alphabet is roughly the same size, there wouldn't be like a big difference.
Cool. Okay. I've got a couple of questions here from Carsten. I'll start with the first one, and he's asking about about your schedule. He said he got an email from someone indicating that the first access to the dataset will be available November, December this year. So how are we looking with the schedule?
Yes, Carsten, you're completely correct that we are slightly behind schedule. So this was like due to many things. Like basically, I guess we didn't really think in terms of in the first iteration. That's also the iteration where we have to set everything up. But we had set the duration of each iteration to be identical. So we didn't really included in the plan that the first iteration will of course be a bit longer because there will be like a lot of the setting up and creating the annotation software and so on. So we are 1 to 2 months behind that schedule. Thankfully, there is a buffer because the project is 3 years long, and the original plan was to finish all 4 iterations in 2 years. So we have some buffer in that sense. But we do plan to catch up in the sense that now we have the setup, and we have hired a bunch of student helpers who help with all the like setting up recording sessions throughout the country, meaning that the second iteration onwards will be hopefully be a lot quicker and more efficient than the first one was. So we still aim to finish at the same time as we did originally.
Right.
But yes, you are correct.
Okay, cool. So is it possible to get early access to the dataset now? He's also asking.
I'm afraid not. Like we do expect to release it fairly soon, like in a month's-ish time, like during January, but we can't release it as it is right now because it hasn't gone through the validation process yet. So unfortunately, especially in the conversational aspect, some of the speakers are they are saying, you could say, personal identifiable information about themselves, and we want to clean up that data before releasing it to the public for the sake of their own privacy. So we are not able to release it until we have done that, which we expect to be 1.5 months time. Of course, there's a conversational transcriptions as well, but we could potentially release the read aloud part of the speech, which is a lot easier to deal with fairly soon. Probably, again, not until January, beginning of January in that case, because of Christmas. But yeah, so we could release it in 2 batches, so to speak. But yeah, January is the current goal.
Cool, and the questions keep rolling in. There's Carsten. He's a very solid contributor here, so that's really amazing. I'd like to include also a question from Henrik, who's asking if you have any thoughts on including dialect samples from the use of Danish on Faroe Islands and Greenland.
That's actually something that we have considered already. Like for pure budget reasons, it's not included in the current scope of the project, but we are in contact with several agencies, like part of the state, to apply for specific funding, extra funding to include these things. So this would be setting up, well, both travel costs and setting up recording studios, if you will, like recording setups in both Faroe Islands and Greenland. So that's already an ongoing process, which we hope will go through, because that would be amazing to have that variation as well, to have a complete picture, because those are the 2 ones that we are currently lacking.
Okay. Can you elaborate? Carsten's asking again. Can you elaborate on the labeling, or point to a webpage where I can find this information? Do the labels contain classification of the 12 dialects, age, gender, etc.?
Correct. They will contain they will contain as much information as we are allowed to, basically. So we can't give specific information about the individual, like in terms of like, of course, their names and so on. They will just be speaker 1, speaker 2, and so on. They will have the dialect, like one of these 12 dialects that will be a part of the data. Age bracket will be part of it, gender will be part of it, whether they have an accent, and if so, where that accent is from will be part of it. Like where the accent is from might be grouped in terms of like language family. But yes, this will be available. We do not, like because the data is not released yet, this cannot be found on any website currently. When we release the data, of course, this will be well documented in terms of like exactly what kind of data is or what kind of features is available in the dataset. And the dataset will, of course, be, well, it will be open source, so you can also just download it and have a look at them yourself. But currently, there's no online resource where that's disclosed.
All right, thank you very much. I've got a question here from Tijana, sorry if I mispronounced it. Your thoughts on best ways of monetizing Danish speech recognition? Could perhaps DR's news anchor live subtitles be improved? There also are already a lot of products, gadgets used for cross-translation of different languages. Will Danish be included in the future?
I can give you a little bit of leeway then on this one. So let's start from the bottom.
Yes.
Here, will Danish be included in the future? Yes, I think it will. And I also tend to think that to a large extent it will probably be very good for a lot of consumer products. I don't think we will be left behind like Microsoft, Google, or the others. In general, Denmark is a very digital country, and which means we're a really good pilot country to go into, and therefore we do actually get more attention than our size probably justifies. So yes, I definitely think that Danish will be part of that in the future, either by the large players or by smaller players like myself. And then in terms of monetizing, I think most of the potential right now in Denmark is with automation. So it happens a lot in like any kind of process automating, especially things that takes up a lot of manual work for like writing summaries. It could be interviews. There's a lot of these interactions where we actually, especially when you have knowledge workers of high education or very specific knowledge, take like what I do, for instance, we try to monetize, making it easier for a financial advisor to make all of the documentation that is required for whenever you call your bank and whatnot, right? So there's a lot of regulation around that, and it does take up a lot of time. So I think is actually a large opportunity there. Then of course I hope at least that, and I guess a lot of the global reports points to this as well, right? It is a growing market, and I don't think we've seen very much yet. I hope very much that we will see a lot of innovations with speech recognition, and that kind of brings me back to this point that we talk and listen a lot when we are awake, right? And we've kind of been accustomed now that whenever we interact with a computer, it's through a keyboard, and we write emails and we read emails and whatnot, right? And then we talk to our colleagues, and all of a sudden now what speech recognition does is it kind of allows us to take that modality, which is so deeply ingrained in us, and create a bunch of products that uses that. So I think speech recognition's biggest promise is that we will actually start to interact with our devices in an entirely new way. And I think it will probably over time be one of the preferred ways of interacting with actual artificial intelligence. So if and when OpenAI or somebody else actually succeeds in creating AGI, then speech will be important for that, right? And I think some of the work that Meta is doing with Seamless is also an indicator that those are the global trends, and speech recognition is a part of that.
I should also mention, like in terms of kind of hands-on practical applications of these kind of speech recognition models, like straight off the bat, will be, well, it's super broad, but like some of the key things, key applications could be a lot of the workers within the healthcare sector. They currently need to do a lot of paperwork, which they have to, like, this could be like socio assistants. They have a little iPad with them where they have to type in every time they go visit a patient. And it has been shown in several studies that, like, we can talk a lot faster than we can type. So if they were able to just, after they visit a citizen, then they can just like quickly say that, oh, I went to this person and I did this and they said that, and so on and so forth. A system like this could then translate that into text, of course, and then potentially also group it into like the name that you visited and so on. Like, this would reduce the time spent on paperwork and more time like doing welfare. So that's one aspect. Noticed in the Q&A that you mentioned subtitles as well. This is, of course, a big field and would help with that as well. Call centers is another huge aspect where this could be helpful. A lot of companies, they want to analyze their calls, like the calls that you get, like what are the typical issues that are there related to. This could be, well, again, citizens. This could also be related to a product of a company and so on. And this would enable those kind of analyses on a larger scale. So there's like, yeah, those are only a few of the applications, and you can like keep coming up with more because, well, it's speech. It's a core part of what it means to be a human. So it will have applications in so many different domains.
I'm actually very happy that you're giving your perspective of the use of this, because this was some of my questions here. Like, in 10 years from now, say, how do you think practice will have changed for, say, a doctor, or for even the person visiting the doctor? What will it mean for the practitioner? What will it mean for the average Danish?
So I can give an attempt. So this is, of course, 10 years is a very long time in this field. So this will be pure.
Let's say 5.
Exactly. So what we have seen so far, it seems like a lot of this field is moving super fast. But if you take a bird's eye view, like it's not moving crazy fast. Like, people have been saying we should have flying cars for like decades now. So I don't think anything like really drastic will happen within 10 years in that sense. But what I hope will be the case is that we have set up systems that ensure that doctors are able to, say, record consultations between them and a patient. And based on that audio and resulting text, that they, again, can reduce like their paperwork to basically nothing, so that they can focus on their patients. The main problem with this, of course, is privacy. Like, how do you deal with all of this very personal text? Like, how do you store it? If you store it at all, that would be amazing. If you don't have to store it, if some new fancy gadget comes up which enables us to do that. But if we could utilize that technology in a way that maintains the individual's privacy, that would highly like make the entire, at least health sector, so much more like efficient, in the sense that they can actually focus on what they care about. Like, they don't have to focus on doing all this admin work in between patients. So that's at least one aspect. I think smart assistants will become a lot more common, probably. Maybe we will have some aspect of, like the Google Glass kind of thing, or some aspect of it, because the product is kind of already there. It was about like the public did not, like, it was too sci-fi, I guess. But maybe it will be less so, or maybe it will be framed in a slightly different way. But maybe that will enable us to have a kind of a smart assistant at our fingertips at all times. So we don't need like this kind of bulky phone in our pockets, but we can actually speak to our technology rather than use our fingers. That would be some guesses from mine, but again, 10 years is a long time. I don't know if you have any other guesses, Martin.
No. I think you went out on the ice here, so I'm just gonna let you fall through, or maybe not. You'll get all the fame. You'll also get all the play. No, I agree to a large extent. I think it's worth emphasizing. I like the very concrete value add I think that will be there is that we as citizens will probably experience more lean processes. Maybe not so much on an individual level, but I think like the statistics will show that there will be more people coming through, and hopefully that means that the quality of service will not decline, even though it should. So I think that's going to be a major thing that can be felt on both sides.
All right, thank you very much. We're kind of wrapping up here, but I'd like to ask you just a couple of questions about the whole process. What have you learned about collaboration in this project? Can you say anything about that?
Learned about collaboration. I guess one thing that I have learned is that collaboration between, well, I guess I had a suspicion that this was the case anyway, but collaboration between small teams is so much more efficient than collaboration between a big bunch. So as we saw in the beginning of this webinar, there's quite a lot of players involved in this project, and working together with every single partner at the same time, like in one big group, doesn't really work because there are too many schedules, too many people, too many kind of, you could say, opinions about the individual bits, where if one divides and conquers, so to speak, like if you split up the project, which we have done, there is a data collection group, focus group, if you will, who focuses on that and who have regular meetings among themselves. There's a modeling group where, for instance, again, Martin and Asan from Alvenir and myself are, amongst others, part of that group, where we can discuss modeling matters and so on without it having to be like a big forum of 20 people who are working on that together. So I think keeping it very small has really shown its worth and its efficiency, and small meaning like very small, like at most 3 people kind of thing. That's at least a big thing that I've experienced.
Couldn't agree more.
All right, thank you very much. Final question here. So based on what you know now, what advice would you have given yourself before you started this project?
Well, I have one, and I think it's probably not true because I would probably not have given it to myself, as it's been like going through all projects that I've ever had, but just legal stuff. You can never start too early with legal stuff. So I think I will give myself that advice now. For whatever we're doing in 10 years, we should probably start today. It's just a headache every time. And especially when we're doing, so I think that's probably the point that I want to get out here is, as I said, we're doing this the right way. And I put that in quotation not because we're not doing it the right way, but we need to, right? It's publicly funded. It's going to be public. It's going to be the first data set of its kind with biometrically identifiable data. So there's no precedence for this, right? And that means that nobody's really willing to take the risk, no matter where you ask. And because we're doing it right, we do ask. That's one of the issues of being a big project, is that you need to do it that way. Because if we had just been 3 people in a basement, we would probably just done it and then ask for forgiveness, and nobody would have really batted an eye. But because we are a large group of well-known organizations, then we need to do it right. And that does take up, so like it influences the schedule, and you can have all these great ideas and a good project plan. And I'm actually quite proud that we are mostly on schedule. That's definitely a testimony to what Dan just said, right? It's that we're working effectively when we are allowed to work. But I think there's just a general rule when collaborating like across organizations, especially collaborating on something which is relatively high stake. It's just take whatever you think you're going to spend on legal and then times it by 2.5, and then you might not get too sad.
And I guess the same thing comes into play again, going back to things becoming inefficient when you're more people. Sometimes you have to have more people. Like for instance, in these, we've been recruiting a bunch of student helpers to help out with the recordings throughout the country. And we had severely kind of budgeted or guessed at we thought that it would be a more smooth process, so to speak. But as with like when you involve suddenly 10, 20 extra people, every person is different. Like some people suddenly get ill, some people, like you have to be able to deal with a lot of these consequences and unforeseen circumstances. And that's just what happens when you have many people. And I guess if we were to re-plan the project, we would have set aside way more time to deal with that aspect, because that was one of the things that made us become a bit delayed, is that we had tons of speakers like who wanted to speak, but we needed to get like teams out everywhere in the country all the time and coordinate gathering all this sensitive data in a safe way. And doing that at scale at a national level, it's quite a lot of work, but more work than we anticipated.
All right. Thank you very much, Dan and Martin. I think that's all for now. I would just like to say yes, thank you to both of you, Dan Sotok Nielsen, Senior AI Specialist at Alexander Institute, and Martin Carsten Nielsen, co-founder at Alvenir. I'm sure if you have more questions, they will be very glad and help you out with answering. Or if you want to continue the conversation, please go and look them up on social media. We are. We are Danish Sound Cluster, facilitating the sharing of knowledge, research, and experience. And we appreciate you joining us here today. You can follow us on LinkedIn for updates, and all of our webinars are available on YouTube. You can go follow us there. And if you go to our website, you can watch our brand new film about Danish Sound Day in November, where we gathered the whole sound industry for a great day of talks and collaborations and great inspiration. So you can go check us out on our website. And I just want to say, besides that, thank you very much for joining us, and hope to see you some other time. And take care. Bye-bye.
Take care, everyone. Bye.